So note 7.7, we're going to continue talking about exponential equations here, except we're going to look at if they're growth and or if they're a decay. So we're going to talk about how we can model that and what each of the values represents and means. So let's look at our exponential equation. We learned this in our last lesson. It's y equals a times b to the power of x. That's our general formula. That a is going to stand for your initial value or initial amount. And the b is going to represent if it is a growth or if it is a decay. And we need to talk real quick about what's going to make it a growth. If it's bigger than the number 1, it's going to be a growth. So if we had a 2 or a 3 or even a 1.5, that's bigger than the number 1. So that would be a growth. And for a decay, you're going to have a decimal, in a sense, a fractional number there that is between 0 and 1. So if we just kind of look at our very, very first example here and kind of pick it apart, it has y equals 34 times 4 to the x. So the 34 is standing for your initial value. And it's not times x, it's 34 times 4 to the power of x. If I misspoke there, I apologize. Remember, when we have exponential, the x is the exponent. So this is our initial value, our amount. Looking at what my exponent to the power of x, that value is 4 is the base. So 4 is bigger than 1, so this is going to be a problem that is going to represent growth, meaning getting bigger over time. So I've just got 2 more examples, and we're actually just going to kind of set it up and find out what the values are. And I bet you can guess with 2 more examples, one will be growth, one will be decay. Let's jump right in and actually set the problem. Determining if it's growth or decay, we have to look at the value of b. The value of b is greater than 1, it's growth. If it's less than 1, it is decay. That's it. So example 2 talks about we have 1,000 fish. We're decreasing, or it's decreasing at a rate of 6% every year. And how many fish are going to be left after 6 years? So to start with this, we kind of need to plug our numbers in where they belong. And think of your formula as the y equals abx, a times b to the power of x. And our initial value is we have 1,000 fish. So it's going to go in for a. And we got to think about this decreasing. We know it's going to be less than 1. And we're decreasing by a percentage, by 6%. So as we plug that in, we're just taking 6% away from the whole number 1. 6% less than that value of 1 to the power of x. So if we think about what that decimal is, think about 100 pennies. You take 6 of them away. We have 1,000 times 0.94. That represents a decay or a decrease because it's less than 1. And to find out after how many fish are left after 6 years, we're going to put that to the power of 6. And if you type this in your calculator just like you see it, it is going to end up with a decimal answer. When we talk about fish, we're either going to have a whole fish, so we can't have like half of a live fish. So I would accept either the 689 or 690 fish left. So after 6 years, every year it's decreasing by 6%. We now have 689 or 690 fish left. We want to round to the nearest whole there. So that's an example of decreasing. Let's talk about if we invest money in a bank. Look at our last example. So if we're investing $20,000, that's going to be your initial amount. So we're putting it in a bank account, investing it, and we're leaving it alone. And the account is going to pay 5% annually. So that means that it's going to increase by 5%. So instead of subtracting from 1, we would add 5% to the number 1. We want to know our balance after 10 years. So that exponent would be to the power of 10. Be careful when you're taking 1 plus 5%. That's like saying 1 plus 5 cents. 5% as a decimal is 0.05. So we would have y equals 20,000 and 1.05 in parentheses to the power of 10. Type that in your calculator, and if you left that 20,000 in that bank account over 10 years with 5% annually, you'll end up with $32,577.89. And of course, we're talking money, so we can round to the nearest penny. So again,